this video is on acid and base neutralization reactions. So if you remember way back in first semester, we learned how to balance all sorts of equations and stuff. One of the ones we did was acid and base neutralizations with a strong acid and a strong base. I already made a video on how to write those equations and stuff, so I'm just gonna link it or whatever, So you can just review that if you need a refresher. The key thing is that it's a strong acid and a strong base, and so also just remember how to name them and stuff. But let's do an example of what we're gonna use these acid-base neutralizations for now, what we're gonna do with them. So say, this is going to be the same equation from the concentration video. So what volume of 1.15 molarity of, not right now, magnesium hydroxide is required, there's a 9 there, required to neutralize 74.92 milliliters of 1.88 molarity hydrobromic acid. Okay, so first step is we need to write the balanced equation. So we have our base. Bases are hydroxides. O, it's a base. You remember that. We have our acid. We see the hydro, so that means there's no oxygen, and we just know it's hydrobromic. And then we have, let's see if I can zoom in. Okay, and then we have our salt, which would be, those are our two, our metal and our non-metal. And then we have water, because we have a strong acid and a strong base. Now remember how to balance these. You want your OHs, your Hs, your waters to be in a 1-to-1-to-1 ratio. So we have 2 here, we have 1 here, and we have 1 here. So we need a 2 here, 2 here, and now it's balanced. So just remember that trick. So now that we have the balanced equation, let's kind of write down what we know. So for magnesium hydroxide, we know its molarity. We don't know the volume. For hydrobromic acid, we also know the molarity, and we know the volume. So we're going to start with hydrobromic acid, and our first step is going to be to find the moles. So remember, moles equals molarity times volume, so that would be 1.88 milliliters times 74.92 molarity times milliliters. Now, since we're going from volume to volume, and it's not a solid, it doesn't say it's a solid, we can leave it in milliliters. We don't need to convert to liters. If it's going to make you feel better to convert to liters and it's easier to remember it that way, go ahead. It's not going to change the problem. Well, I mean, you're going to get the same answer. It's going to be in liters. It will come out the same, but you can leave it in milliliters. So that gives us, I went on my tangent, 141 moles of hydrobromic acid. Remember, you want to use this unrounded answer in your calculator when you continue to do the steps, but for right now it's fine. So now we have moles. So now we need to convert these moles to the moles of our unknown, because we're looking for this volume. We don't know what the volume is. So we can do that with a mole ratio. So we're going to start with our moles of hydrobromic acid. We go back to our equation. We see we have 2 moles of hydrobromic acid for every 1 mole of magnesium hydroxide. And that would give us 70.4 moles magnesium hydroxide. Okay, so now that we have that, now we can solve for volume. We know from our equation, volume is moles divided by molarity. And so that gives us 91.2 milliliters of MgOH2. So this is just for strong acids and strong bases. No, that's how you can use that formula. Go away. I don't know what that is. Mole equals, oops, nope. Go away. Okay, molarity equals mole over liters. You can manipulate it. Say it asks you to solve for molarity. Then you can switch these. Get your, just do that. No. But yeah, so that's what we're going to use the stuff we've been learning about with acids and bases. The next chapter is all about acids and bases and stuff. So there will be more of this coming, but for right now, that is it. So thank you so much. Let me know if you have any questions.